Hello. This word problem deals with angle of elevation. Okay, and angle of elevation is always seen with the horizontal. Okay, let's read the problem and try to understand. Angle of elevation of a tree is 30 degrees from a point A and 60 degrees from another point B, 25 meters closer to the tree. Determine the height of the tree. Okay, so basically it's saying that, let's say this is our tree, correct? It says angle of elevation of the tree is 30 degrees from a point A and 60 degrees from another point B, which is 25 meters closer. So let's say this is our tree, so angle of elevation is, let's say, 60 degrees from this point and 30 degrees from this point. Okay, so what we have here is A is this point, which gives angle of elevation of 30 degrees, and this is B, which gives angle of elevation of 60 degrees, and B is 25 meters closer to the tree than A. That means if A is distance D away, then B is 25 less. That means this distance between A and B is 25. Correct? This distance between A and B is 25. Now what do we need to find? We need to find height of the tree. Correct. So we are again going to use special triangles. So it's a good idea to draw our special triangles once again. So here let's make our special triangle, and the special triangle is here. So if it is an equilateral triangle, where I haven't seen, this is like half of equilateral triangle. Let's say this is my equilateral triangle, okay? Now with each side of 2. So this is 2 and this is half of 2, which is 1, and this side will be square root 3, correct? And the angle here will be 60 degrees and this angle will be 30 degrees. Okay, so let me write those angles in a different ink. So this is 60 degrees for us and this is 30 degrees. Okay, right. So we'll use this special triangle to find the trigonometric ratios. Now this tree, we'll assume that this was at a right angle to the ground, correct? Now since we need to find height and we are given something here 25, we don't know this. Let's say assume that from, let's say from this point O, origin 0 of the tree, let this much be x distance away. Okay, so that is a scene, and you know the angle of elevation of the tree is 30 degrees from point A and 60 degrees from another point B, 25 meters closer to the tree. Determine the height of the tree. So our diagram actually represents the problem, correct? So here is a tree, and angle of elevation from A is 30 degrees, from B 60 degrees, and B is 25 meters closer, right, to the tree. To find height, we can use tan, right? Because we are trying to relate this, which we'll call as our base, and that which we'll call as our opposite side. And I hope you remember SOHCAHTOA, right? Sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan is opposite over adjacent. So since this is opposite to these angles given, and this is adjacent, we will use tan, correct? So that makes sense, right? So let's start with tan of 60 degrees. So what is tan of 60 degrees? So say tan of 60 degrees is equals to h over x, right? And from our special triangle, we say tan of 60 degrees is square root 3 over 1, right? Opposite over adjacent, right? So we'll write here square root 3 over 1 is square root 3 equals to h over x. So we got our first equation. Now we'll use the bigger triangle. Let's say this is treetop T, okay? So bigger triangle is TAO, and in this triangle, tan of 30 degrees is how much? We say tan of 30 degrees is equals to h over 25 plus x. So we get h over 25 plus x. Correct. And tan of 30 degree from our special triangle is 1 over square root 3. So we say 1 over square root 3 is equal to h over 25 plus x. So now you see we have two equations and two variables. At this instance, we can also find the total distance of A or B from the tree. Well, they're not asking for it at present. Sometimes a word problem may ask for it. And we can also find h, right, which is a part of our question. So that means if we need to find h, let's eliminate x. Correct? So from our standard equations which we have here, we'll now try to eliminate x and then write down equation in one variable and then try to calculate it. Now see here. So from here we can say x is equal to, we'll cross multiply, is x is equal to h over square root 3, correct? That's it. And here also we'll simplify the equation, trying to get rid of fractions for the moment. So we'll write here is, we'll just cross multiply. I hope you understand cross multiplication. One, basically think like this. We are multiplying by 25 plus x both sides. So when I do this, this gets cancelled and here we'll end up with 25 plus x. And we are also trying to multiply by square root 3. So when I do square root 3 times this, then this square root 3 cancels. And here we get square root 3 times h, right? So we'll say h times square root 3. So this is in a way cross multiplication, right? This term which we have here actually goes to this place and the term here goes to this place. Just as we did here. Do you see that? X went here and square root 3 came down, correct? Cross multiplication is a very, very good technique to use, especially when we have some ratios like this, right? Now since we have now two equations here and we know what x is, we can substitute this value of x here, then we'll have equation only in h, right? And then we can solve for h. So let's do it. So we'll write 25 plus x equals to this as 25 plus, instead of x I'm writing h over square root 3, okay, equals to h square root 3. Correct? Now at this stage also we can get rid of fraction by multiplying everything with square root 3. Better we get rid of fractions rather than making them common denominator and doing it all the time. Correct? So I hope you understand what I'm trying to do. I'm trying to multiply by square root 3 at all the places. That means I'm doing this with square root 3, I'm doing this with square root 3, and I'm multiplying this also with square root 3, correct? If I do that, then what do I land with? I get here 25 square root 3 plus, this cancels, we get h here, and square root 3 times square root 3 is just the number 3. So we get 3h. Correct? So a lot of things have happened here. Let's go through them once again. So initially we had tan 60 equals to h over x, and tan 60 is square root 3 over 1. So we read square root 3, and then we wrote x in terms of height, right? And we got x as h over square root 3. Now for the other triangle, the bigger one, tan 30 was h over 25 plus x, right? The whole base, right? And tan 30 from here is 1 over square root 3. So we wrote here. And then we simplified this expression by cross multiplying. We got 25 plus x here and square root 3h there, correct? Now substitute the value of x from equation on the left to the equation on the right. When doing so, we get 25 plus h over square root 3, and here we have h square root 3, correct? So we have now an equation in single variable, and the variable is height for us, in which we have interest, right? Because the question says determine the height of the tree, correct? Now, to simplify this equation, we multiplied every term, these are my three different terms, by square root 3. In doing so, I get rid of fractions and I get 25 square root 3 plus h, very simplified expression. Do you see that? Now, I can simplify this. I can take h on this side, so we get 3h minus h, and here we get 25 square root 3, and 3h minus h, you know, is 2h, correct? So this implies that height is equals to 25 square root 3 divided by 2. So we got our height as 25 square root 3 divided by 2. So as I always emphasize, it's a word problem, so you need to write very clearly what the answer is. Don't ever forget to write answer very clearly, okay? Now it says determine the height of the tree. So you say height of the tree is how much? Is 25 square root 3 over 2, correct? And what are the units? Units are meters. Don't forget meters as the unit, or the units in the question, right? I've seen many times, sometimes students don't even write units. Sometimes students will do all the effort to solve the problem but don't write the answer. Now, how will a teacher know that from this sheet of paper what is the real answer, right? So it's very important to write the answer clearly, okay? I hope you understand the approach and it helps you to solve similar problems, okay? We have used trigonometric ratio, simple trigonometric ratios, because they were right angle triangles. We are not using any sine law, cosine law for doing this. It could have been done, but no need, right? Now, let's go ahead and do some more problems so that you get good practice, okay? Thank you.